I'm going to say if I see, okay, if I see, and then I'm going to say something like A. And then the usual form of this guy is like, for example, you have, I think that you said, I can't remember, but I'm going to put B squared plus A squared x squared, right? Then what is that trigonometric change that I have to do? So my trigonometric change is going to be x equals 2. I need to get rid of this A to be able to factor out the B, right? So I'm going to say my x is going to be given by B over A. And then I need a formula that gives me, after I factor out this the B, I'm going to get 1 plus. Okay, so what happens now? Let me put it in here. So not in here, over here. So if I have B squared plus A squared x, after all, A squared. And I need to put more stuff here. But I want you to tell me what I need here. So, if I plug in these positions, B over A, instead of my x, I'm going to have B squared plus A squared times B over A. And then I'm going to put something here, squared. Correct? All this is inside the square root. And then, when I square these things, then I'm going to have B squared plus A squared, B squared, over A squared, and something here, squared. Now this A, I'm going to be able to cancel out. Yes? I'm going to be able to factor out a B. I'm going to have here B squared, 1 plus, I don't know, something here squared. And then this B is going to go out. So I'm going to have B square root of 1 plus something squared. And I want an identity here that lets me get rid of this miserable square root, right? So what is that? I know that 1 plus tangent squared is equals to? Is equals to?
Secant squared.
Secant squared. So when I see B squared plus A squared times x squared, my change of coordinates should be B over A secant of theta, right? Because then I go, 1 plus tangent is secant, right? Tangent of theta, right? Because when I put it over there, if I put my tangent over here, tangent square of theta, 1 plus tangent square is equals to secant square. So I can replace all these 1 plus by secant square. And then the square root of that is just going to be B times secant of theta. Correct? Yes? So you see what I mean? Why are you looking at me like that? You're supposed to know this because he said he covered this part. Okay? Now, this is not the only possibility. This is one possibility. Now there is another possibility, B. What if instead of a plus here, I have a minus? Okay? What if I have a minus here? So now I'm going to have this. B squared minus A squared x squared. What is my change of coordinates? So as you understand from this computation, I have to have B over A. X has to be equal to B over A. Of course, I'm not thinking that A is 0, right? Because it doesn't make sense. If A is 0, then what am I doing here? Just get the square root of B and that's it. So, what should be the thing that I have to put here instead of tangent? Because tangent is not going to work. What will work? Huh? Exactly, sine or cosine. For example, I'm going to say sine of theta. Why is he saying that? Because now, all what I have to go is change a minus here. Instead of a class I have a minus. Now, he told me I have to use sine of theta. Then this becomes a minus. I have a sine of theta over here. This is a minus. I have a sine square of theta over here. And what do I know? That 1 minus sine square of theta is equals to cosine of theta. So I'm going to have here a beautiful cosine square of theta. And square root of that is going to be p cosine of theta, which is something that I can work with. Correct? Yes? So this is very easy to deal with. Now, if I have another case, I cannot move this. So I guess that because I got all that. Alright, so what if I have now, I'm going to change it. Now it's going to go like this. A squared x squared minus b squared. I just flip that side. But I need a different trigonometric identity. So my secret here is that I know, this is like in a parenthesis, what I'm using here is that I know that 1 plus tangent squared is secant. Yes? You read this. And then I'm using here that 1 minus sine square of theta is cosine. And I don't need here, what do I need to do here? B over A, but now what do I need? Now I don't have this case anymore. Now what I have is the other way around. So I need another trigonometric identity like this, but that gives me something. So what I have now is this. I have a squared, x squared minus b squared, right? And I said I'm gonna do my x equals to b over a, so same deal here. A squared b over a, but I need to put something there. B squared. And then, so what do I need? Secant? Secant? Okay, I was told secant. Let's try secant. If I try secant, they are trying to tell me that the formula they are using is now one that looks like secant squared minus 1 is tangent squared, right? Yeah? Come on, I need some more support here. Yes? Okay, so that's what they told me. Let's see. They told me to put here secant. So if I go over here, I'm going to put here secant. Right? So if I cancel out, this is going to look like this. A squared, b squared, a squared, secant square of theta minus b squared. Cancel your thing, factor out to b, and you get secant square of theta minus 1, which is going to give you tangent square, right? Etc. So it's very easy. Yes? Yes? Okay, so those are the possible trigonometric substitutions. Any questions? Any questions? No questions? Okay, so let's do it. Yes. What is this for? To solve an integral that I'm going to give you right now. This is not just blah, blah, blah. It's that I have a reason, right? And the reason is that I want you to solve the following integral. I want to give you the first part is going to be a bigger question, so you tell me what is the center coordinate. And then I finish the integral, okay? So, So, where are we? So we're going to solve right now problem 11 in section 5.7. So this is section 5.7, problem 11. And it says like this. It says, find the integral of the square root of 9 minus x squared over x squared dx. Okay? So you don't need a book. You just need to see a problem. And then my little question is going to be, what is the substitution that I have to do? Yes? And then I'm going to give you some possibilities. Take my center coordinates should be 3, x equals to 3, and I just use all what I have there. 3 tangent of theta. B equals x equals to 3 sine of theta, and then C equals to 3 secant of theta. Okay, little question. So let's open that. What can you do? So I'm opening the web page. Now I'm going to open the key. Okay, so when you choose your change of coordinates. It's a critical moment, right? I only want to know what it is, the x that I have to take. I don't want you to solve the whole integral. Are you done? Then why is it taking so long? 90. Come on. Are we done?
No.
What's the problem? I have other formula there. I have that formula here. What's the problem? Are we done?
No.
Yes. Okay, are we done? I'm gonna close it, okay?
Wow.
Good. If I don't close this, then I get in trouble. Okay. So, what was the change? A, B, or C? B, of course. B, and it's very clear because you have a beautiful minus, and I told you whenever you see a beautiful minus there, you have to do this change. Yes? Your B is equals to 3, your A is equals to 1, what do you have to talk about? Nothing. Okay, so that's your change, so let's do it. So, if x is equal to 3 sine of theta, then I just have to plug in everything there, just have to substitute all these values in there to solve this integral. So this is going to give me 9 minus 9 times the square of theta over 9 sine square of theta. And now I need to figure out what is dx. This is 3 times cosine of theta in theta, correct? Okay, so now, what do I know now? Okay, so what I know is that I can factor out the 9, as I promised you. That's why I made a change of coordinates, because I want to be able to factor out the 9. So this is going to be a square root of 9, 1 minus sine square of theta over 9 sine square of theta. And over here I have what I have to put 3 times cosine of theta and theta. So I can simplify and just this 9 is going to go out like a 3 times 3 is 9 divided by 9 is 1. So I'm going to get cosine of theta. Okay. I'm going to simplify it like this and let me know if this is clear. Okay, that was too fast. Too fast? Okay, slower. Is it clear why I got rid of the 9s? 3 times 1 minus sine square of theta is cosine square of theta. And I have a 9 here, and I have 3 times cosine of theta here. Correct? So 3 times 3 is 9 divided by 9 is 1. So this is cosine of theta times cosine of theta over sine square of theta d theta. Yes? So this became cosine square of theta over sine square of theta d theta. Okay, now I need help. How do I solve that problem? I have a problem. I have to solve the integral cosine square of theta. So all my integral that look like this now looks like this. How do I solve this problem?
Make it a cotangent square of theta?
Cotangent square of theta. And then the square root kill cosine square of theta. Because you have a square root of cosine square of theta, so when you take the square root, then you have a square, these cancel each other. So the right inside becomes cosine of theta. Yes?
Why did you multiply by cosine after?
Because I have to multiply by dx. And dx happens to be 3 cosine of theta d theta. That's why I multiply by this. Okay, my friends? What is the deal with cotangent? Is equals to? This is the funny. What is cotangent equals to? Huh? Negative cosine? No, forget it. Yes, it is. There are two ways of getting to this formula. This is equal to 1 minus cosecant square of theta d theta. Right? There are two ways of getting there. One is remembering this. One is just looking at this. Or the other one is just changing these guys. So this is the same. By, 1 minus sine square of theta. And then divided by sine square of theta. And then as you see, you get 1 over sine square is cosecant, right? Minus 1. So this is cosecant square minus 1. So it's the other way around. According to my formula, this is cosecant square minus 1. Correct? This formula says it's 1 over sine square, that's cosecant square minus 1. So that's the correct formula. Okay, and now we are lucky because we have an antiderivative. We have a formula for this cosecant square. And this is easy to do because this is just theta. So this is just theta. And what is the integral of cosecant square? Cotangent? Cotangent? Negative cotangent is equal to cosecant square. So that's it. That's the answer. Okay. I'm not done because I still have to solve for x, right? My problem started with x, correct? My problem started with x, and now all what I have here is 10
arcsine.
The arcsine. So theta is going to be equal to arcsine of x over 3. So what I can do here is write this is minus cotangent of arcsine of x over 3 minus arcsine of x over 3 plus 1. That's my answer. So this integral that looks horrible is much easier if I change it to that. I mean easier. I'm not saying it's easy, but it's easier. Okay, questions? Okay, so let's do the, I'm going to do 16 because 16 is the definite integral from 0 to 2 over root of 3 of x cubed over 18. I don't like it because it has a minus. And I don't want to do minus because I want to do 0. I want to do 18. So 18 is the integral of x cubed over square root of x squared plus 1 dx. Okay, this is easier. So what is that change of coordinates, my friend? What is it? How do you want to integrate that? Maybe you don't want to do what I want. How do you want to do it? See, I have mixed feelings. Right now I have mixed feelings. Should I tell you my mixed feelings? I kind of want to do it like by parts, and maybe I'm going to need a substitution, trigonometric substitution. But I don't know if I should just go straight to trigonometric. So I have these two problems in my head right now. I kind of want to do it by parts, but I also want to do it like trigonometric. I don't know. But let's try trigonometric. Alright, what is my change? X equals to what? Tangent? Beautiful, because I see a plus. I said, in all these, I don't have a problem because this D is 1, this A is 1, so X is equal to tangent. Okay, let's go for the rest. Alright, so what's the derivative of tangent? Alright, so now I go here, and then I want to change. My X is going to become tangent, Q. And I'm not going to worry about that now. Now, over here, I'm just going to put integral over square root of secant squared of theta plus 1. And my dx, what am I doing? Tangent squared of theta plus 1, and over here I have secant squared with theta. Correct? Check on me because then I start thinking on my boyfriend and I forget what I'm doing. Is this right? Is this right?
Yep.
Okay. Alright, so what is tangent squared plus 1? So how does this reduce? It looks like tangent cube theta. And what is in the denominator? Alright, secant squared of theta. And then I can continue this now. That's why I put it there. Okay, then I have the following. I leave my tangent there, I don't care, this is right there, it's not bothering me. And then I'm going to take the square root of this secant, which is going to become just secant. Yes? Yes? Okay, so far this that looks like tangent cube of theta, secant of theta, is theta. Yes? Any questions? What is next? Okay, first out. Can I use, what is the derivative of tangent? Secant squared. So this is not going to help me, correct? It's not going to help me because to be able to use substitution completely, I will need to have a square here, and I don't have it. Right? So I cannot do that. So I cannot just integrate this tangent as a 1. What can I do there? Explain it? What did you explain? Tangent square of theta? There tangent secant of theta. And then? Okay. Secant squared. So you are telling me I write secant squared. Tangent squared equals to secant squared minus 1. Okay, now I understand. So what he's saying is that I have to use my formula. Tangent squared equals to secant squared minus 1. So let me put it there. So he says use your formula. Secant squared theta. Tangent equals to secant squared of theta minus 1. And then, I guess you want me to put my secant here and my tangent here. Secant cube theta. Yeah. Okay. This, call this to you. Okay, I don't understand. Call u equals to secant of theta. Okay, then du is equals to secant theta tan theta d theta. Okay, and then this in business. Because now what he's going to do over here, he's going to say u squared minus 1 times du. And that's a trivial integral. But don't go so fast because we have to go backwards. Right? You understand the problem? Now we have to integrate that and then we have to go backwards. Because there are several changes. constant. But I'm not done, babies. I'm not done because U is secant of theta. Right? Agree? So this guy has to be replaced by secant of theta. So go back here and then we say this is equals to secant cube of theta over 3 minus secant of theta plus 6. Am I done now? No, because what is theta? From this one, what is theta? Exactly. X theta is equal to I tan of x. So now I have to replace my theta over here. So I have to say this is 1/3 secant cube of I tan of x minus secant of I tan of x plus c. Very good. This good, yes.
I just read the basic denominator and the secant of
Here?
the top chord. The denominator. The top chord
Oh, the top chord
to the right.
to the right.
The denominator. I just read on that.
Here?
Yeah.
Because this formula we know that 1 plus 100 square is secant square. And we know. We have it over here. 1 plus 100 square is secant square. Okay? So this is clear? This is clear? So we are done with this. Well, I am done. You have to do more problems. But this is trigonometric substitution, and you got an idea of what is what you have to do when you have this kind of problem. Yes? This that I wrote over here is very helpful because it tells you what to do. And then just hope for the best. Yeah. I think those cover all the things. And I wrote them in Tango General way that I did. Alright, so now I'm going to do partial fractions. So this is another business. I'm going to go here. Alright, so partial fractions. Well, this is divided in 2 parts, but I'm going to talk about the first part today. So we're going to try to solve integrals of this type, okay? I'm going to solve an integral that says, for example, I don't know, let's just say 2x plus 5 over x minus 3 times x plus 7 dx. Okay? So, you know that it's partial fractions because it looks like this. It looks like a product. This is the easiest case. It looks like a product of linear factors to the denominator, and it has something on top. So polynomial whose degree has to be smaller than the degree of this. So what you have in the denominator is something of degree 2, and you have something of degree 1. If you have the same degree, then you will have to divide, and then you will have to do long division, then degree 4, right? But so far this is the easiest thing. So what do? We're going to undo this, kind of undo it. So what we do is we try, let's forget a little bit about this integral and let's go to this side. So this is 2x plus 5 over x minus 3 x plus 7. And what I want to do is I want to divide it in two integrals. So I want to say this is equals to a over a, I don't know what x is, but I'm going to figure it out. A over x minus 3 irreducible, meaning you cannot reduce this polynomial anymore. So it's an irreducible polynomial. Or it cannot be factorized anymore. That's the most that it can be factorized. Okay? And now what I want to do here is I want to take common denominator. And if I want to take common denominator, as you know, that's what I'm saying. I'm not doing it and doing it again. So common denominator is the product of these two. So this is going to be again x minus 3 times x plus 7. And then I check this common denominator with the first factor. And I said, what is missing? Oh, this guy is missing. So this should be 8 times x plus 7 plus, if I compare this with this, what is missing? X minus 3, so it should be plus 3 times x minus 3. And then I'm going to point the top and see what I get. Any questions? Clear? Let me know if I'm confusing you. Alright, so let's take, I like to write over here what I have. So I have 2x plus 5 over x minus 3 times x plus 7. And on this side, I took common denominator, so I'm going to point it, and it's going to look like this. The top looks like 8x plus 7a plus bx minus 3b over the denominator. Yes? Now what I'm going to do is I'm going to put together everything that has x. So this looks like x times a plus b. And then everything that doesn't have x go together. Plus 7a minus 3b. And then I'm dividing over this product. Yes? Yes? I don't know why, what the students find difficult, but I don't understand why. You just have to understand that this side is equal to this side, correct? If two things are equal, then whatever has x, the coefficient, so I can only compare, as I told you in elementary school of kindergarten, apples with apples, pears with pears, oranges with oranges, right? So, if these two are equal, then that means that 2 has to be equal to a plus b. So this implies that a plus b has to be equal to 2. Yes? And therefore, this guy over here, 7a minus 3b, has to be equal to what? To 5. And then this is like the kind of linear system that you were used from the times where you were even younger, right? And then how do you want to solve it? That depends on your taste. So what do you want me to do? I mean, do you want me to multiply by 3, cancel this factor and solve for a? Or do you want me to do substitution here, solve for b, plug it in here? What do you want? Solve for b? Alright. Okay, so from this one, I'm going to say that this equation over here implies that b is equal to 2 minus x. Yes? And then I'm going to replace this equation in the one below. And this is going to say that 7a minus 3 times, instead of b, I write this, 2 minus a. So this is equal to 5. Okay, so that is just algebra. So what do I get? What do I get, guys? I get 7a minus 6 plus 3a, is that right? Equals to 5. Yes? No? Yes? what is this? 20 minus 11, 9 over 10. Yes? Okay, so now everything is easy. My integral became this. So my integral that look like 2x plus 5 over x minus 3 x plus 7 became the two integrals. Became the integral of, I just have to remember what was a. So a is over x minus 3, so 11 tenths over x minus 3 dx plus b, which is what? 9 over 10 over x plus 7 dx. And these are very nice and easy integrals because this is equal to what? The first integral is equal to what? ln of x minus 3 plus 9 tenths over ln of x plus 7 plus c. Nice and easy. Right? Question? Question? Okay, when am I supposed to finish 10:30? Don't have 10 minutes?